In college algebra, we took transformations of functions a little further, and we looked at reflections over axes and how fast these graphs climb or don't climb. So if ever you have a negative in front of the function, it reflects it over the x-axis. I tend to just say it flips down. I am okay with you just saying that. You're probably used to seeing that with parabolas, because we've graphed one of those before, and if we transform it to have a negative on the front, it flips it upside down, because this one is facing up like that, and this one is facing down. And that's all this transformation is talking about. And it works with square root functions. So this negative is on the very front. It flips it down. It reflects it over the x-axis. So if I ask you to describe the transformation, I would personally just write flips down. I like to graph the original graph, the parent function, and that is 0, 0, 1, 1, 4, 2, and 9, 3. So this is the parent function. We learned that yesterday. Versus this new transformed function that has a negative on the front. So if I plug in 0, I still get 0. If I plug in 1, this time I get negative 1. If I plug in 4, I get negative 2. If I plug in 9, I get negative 3. And there's our graph. Feel free to use the calculator or do it in your head. It is up to you, but I need to see coordinates. All right, things change on number 5. The negative is inside the function. This flips it another direction. It reflects it over the y-axis. I write flips left. So you can say reflected over y, or you can say flips left. So I'm going to graph the parent function again. It's good practice. You can get a handle on what the points are for the basic parent function, and it speeds things up when you graph the real problem. So that right there is square root of x. Now let's graph the transformed square root of negative x. It's kind of weird because you can't take a square root of a negative. But if you plug in negative 1, you end up getting a double negative, right? So that means negative 1 goes up 1. And if I was to plug in the positives, I would get an imaginary result. If I plug in 4, I get negative 4, and I can't graph 2i. So I plug in negatives, and I get positive results. Plug in negative 4 and you get 2. Plug in negative 9 and you get 3. And this is our flipped graph. If you need help, plug in 0, negative 1, negative 4, and negative 9. And you'll get those graphs, or the blue graph. All right, what if there's a number on the front? If the number is larger than 1, the textbook likes to say stretches. I like to say climbs faster. Or if you're looking at a parabola, it narrows. But you can say stretched. That's up to you. If it's a small number, like say 0.5, or some fraction smaller than 1, the textbook says shrinks. I like to say climbs slower, or it's wider. So let's look at 2 different examples of that. On this one, we have a 2 in the front. It is larger than 1. Therefore, it's going to make this graph climb faster. You can write stretches, you can write climbs faster, you can write narrower, not stretches. I mean, narrower makes perfect sense to me. Stretches, I don't know, stretches and shrinks, it doesn't make sense to me. Let's stick with red for our parent function. So the parent function of absolute value of x is 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. And there is our parent function. We're comparing absolute value of x to 2 absolute value of x. Feel free to type it into the calculator, but it's pretty easy to do in your head. Plug in 0 and you get 0. Plug in 1 and you multiply by 2, so you get 2. Plug in 2, you multiply by 2, you get 4. Plug in 3, you get 6. Don't forget there's a left side to this graph. Whatever goes into the bars comes out as positive. So negative 1, 2, negative 2, 4, negative 3, 6. And there is our narrower graph. And number 7 has a half on the front. Whoops. It widens the graph, or shrinks, or climbs slower. That's up to you. Wider, widens, shrinks, that's up to you. So one more time, here's our parent function. We're comparing absolute value of x to half absolute value of x. I would pick multiples of 2 to plug in. Because of that fraction, 1 over 2, that'll give us whole numbers. So I would plug in negative 4, negative 2, 0, 2, 4, negative 6, positive 6, and you'll get really nice numbers. Plug in 0 and you get 0. Plug in 2 and you get 1, because 2 times a half is 1. 4 times a half is 2. 6 times a half is 3. Once again, use the calculator if you need to. And we have our wider, let's try again, our wider graph. All right, let's sum up all of our transformations. There's a vertical shift if we add or subtract after the function, after the math operator. It's kind of hard to say in general. If it adds, it goes up. If it subtracts, it goes down. If you add or subtract inside the function, it moves it horizontally. If you add, remember it goes in reverse. It goes left. If you subtract, it goes right. So it's backwards thinking on that. For reflections, if negative in front, it flips down. If negative inside the function, it flips left. Stretching, if front number is large, great, draw better greater than. Then stretches, or any of the other words on the previous page. If front number is between 0 and 1, it shrinks. So let's do number 1 and we'll stop there. I see a +4, that means it goes up 4. I see a -2, that means it goes right 2. So I make a dot on that spot. Up 4, right 2. This is absolute value, so it goes, and there's no front number, so there's no change in how it grows. It just goes over 1, up 1, over 1, up 1. Left 1, up 1, left 1, up 1. And we have our transformed graph. Try again there. And that was it. That was where we stopped on Tuesday. See y'all later. Bye.